Welcome. My name is Bob Tickleman. I'm a Microsoft Principal Technical Trainer. I'm excited to be your guide for module number 2, Explore Azure Event Hubs, part of our event handling process learning path. In another recording, I talked about queues in general. I'm going to do some of that here and realize that this is part of a very valuable process in modern application development in a thing called decoupling. We need to be able to, instead of in a monolithic application, we need to decouple components of our application. And as opposed to talking directly with each other, I need to provide an intermediary source, allowing for a large amount of activity to take place, maybe at a triggering activity. I need to then capture that information, let this process slow down or maybe even go away, and be able to respond to it in kind, as opposed to having a direct one-to-one relationship. For hundreds of thousands of things happening, I may not need to respond to each and every one of them at a time. I want to maybe say if more than 5 of these activities take place, I then need to have a response. Or do I need to respond to each one of them, but not necessarily at the moment in time that they take place? All of these are considerations for you in this concept called decoupling. So we're going to describe the benefits of event hubs versus event grids. I'm going to start with this by going back to another part of a recording that I've done in the other ones, but I'm now going to focus on the event hub piece. When we take a look at this term queues, there are 5 major queues that we take a look at. We're only going to be covering 4 of them over these series of recordings. There are the event-based queues, which we are in currently. In another recording, we covered event grids, and now we're going to take a look at event hubs specifically. The other types of queues are message-based queues, which are going to have payloads be part of its information, as opposed to just some triggering activity and some small bit of information about the object that triggered the activity itself. It could be a sales order that has the customer name, the address, the billing information, and all the items that were put on the order. That would be a message that is stored in the queue, as opposed to just a triggering of a message saying, hey, I created a sales order. Now, I do want to just briefly mention this one here. IoT Hub, all of these 4 queues, the first 4, are one-way directions. You'll see this as we get into the slide. It comes from a thing called the publisher to the subscriber. IoT Hub is a relatively new feature because we used to use event hubs to provide some of this capability. Now, the problem with event hubs, as I said, they're one way. They take streaming information that pulls information from, as a consumer, from the event hub itself. Now, we have no way to push things back. And so IoT, or the Internet of Things, you now potentially have hundreds or thousands of IoT devices emitting their activities. It could be temperature recording. It could be, monitoring to see if the part is turned on or is it spinning at a certain RPM, whatever it might be. You've got all these IoT devices emitting this telemetry information to, in this case, it would have been the event hub. We now have a very specific queue that does this, and it's called IoT Hub. And I want to put it here, it both pushes and pulls and is bi-directional. So not only can I get the telemetry information from the IoT devices, I can push back to those IoT devices configuration and control changes. So IoT Hub, not part of this recording at all, but if you have those type of devices and you typically used event hubs in the past, know that IoT Hub might be a great way to be able to replace that with this bi-directional communication to those devices, as opposed to purely relying on event hubs. So basically, I'm just going to summarize this in an easy term. Event grids versus event hubs. One is this basic tool that does a great job around some standard events that you're going to have, is that everything in Azure is going to be there. In the event hubs, this becomes more of an enterprise grade. And if any of you are using a product like Kafka, where you've used those capability to take this information, this is going to be at scale a cloud-hosted service. So instead of having to install a Kafka server and provision that server, manage it and maintain it, and then be restricted to the capacity of that server that you deployed it to, Azure provides event hubs as a cloud scale capability. So as that hub, takes on more responsibility, maybe grows as the enterprise grows, you don't have to redeploy another Kafka server. this is going to grow with you as a cloud-based service. So I would say this is kind of an enterprise-grade activity tracker in the Event Hub. So let's take a look at what Event Hubs provide for us in this big data streaming platform environment. As I said, the difference between this and the previous one, the Event Grid, it's got some very small amounts of data, it collects it from pretty well everything in Azure or anything you want to publish to it. This is going to become this enterprise decoupling platform for you to build this queue around. And everything we just talked about, let's go and take a look at this. As I said, it's a fully managed platform as a service environment that provides cloud scale capabilities. You only pay for what you use. And so as you build this hierarchical structure, you create an Event Hub account, then you have a hub inside of that, and then you're going to create a set of partitions. And so it follows a lot of other patterns inside of Azure, similar to, like, say, if you remember Cosmos DB, you have a Cosmos DB account, you had a database within the account, you then had containers, very similar to that kind of process without having to go all the way to Cosmos. But the Event Hubs now have a fully managed platform as a service, provides this real-time patching and processing that's being managed by Microsoft, and then it provides that scale. It is enormous capacity depending on what your needs are, and you only pay for what you're using. Similar to the other event handling tool in Event Grid, Event Hubs has a client that you're working with. You have Event Hub producers. And so very similar to, we talked about a pub sub. It still follows that model. If you're familiar with those terms in the industry, you have a client and you have a producer. You have consumers that you're working with, and that would be that pub sub, so the publisher subscriber model you're dealing with. Inside of the Event Hub, you then have a space in which you can store that information. You can have up to 32 partitions, and we're going to talk about that in a few minutes, inside of the hub itself. Now, the time that you create the hub is when you have to mention the number of partitions. At the time of recording, you are not capable of adding partitions to a hub after it's been created. You'll have to then recreate the hub and then redeploy it for yourself. But at the time of recording, you can't do that. So you might want to consider, what do I need my partitions for? Now, they are done for very specific reasons. I'll get to that in just a few seconds. We then have consumer groups, and you'll see this come up on a slide when we have your subscribers. You could then group them in as a set of applications that are going to collectively work on the potential multiple partitions and pulling information out of it just to handle size and scale. So you're not looking at this very linear process of a stream of pumping everything into the Event Grid and then pulling things out the other side. We have this massive capability to put things into different partitions. Now, the default handling, let's say you went to the maximum 32 partitions, the default handling of the publishing would be to then round robin and then just start putting items into the partition itself. Now, that's great if you don't care too much about the order, because the order processing is only within the partition itself. But let's just say if it was numerical, partition 0 had item number 1, partition 1 had item number 2, and so on. So you went through the 32 items. The 33rd item would be back in partition 0, and you would then do that again for 32 items. And so you would have 0 and 33 in that first partition, and they would handle in order in that partition. But you're now going to have what happens if you need it to happen 1, 2, 3. So these all become considerations you need to take a look at. And you do have the capability of now taking those partitions and uniquely identifying information that's coming in. I want you to go to a specific partition. So you can actually name them, or you can say, I want this group of information to go to a specific partition. We're going to show you that as we get deeper into the book. So all of that flexibility to now try and provide that size and scale that you're going to get at this massive enterprise level capability. Now, this is all done through a thing called throughput units, and that's the way in which you pay for the processing you're dealing with. And this becomes a very economical way to manage it. I did a very similar example when I talked about Cosmos DB, because normally you're looking at storage, you're looking at compute capacity, network, all of these different resource types. And in the past, I'm going to go back to Kafka, you would have to determine, what do I need for all of those? And I'd have to provision a server to meet those requirements. The benefit of a throughput unit is it takes that obfuscation and allocates a single throughput unit, regardless of what you're using it for. It's a way to calculate and then pay for it on an economical scale, because the more throughput units that you get, the more you can you get a deeper discount, and the more you can allocate to a specific event hub. You might have multiple hubs, so I can now spread that across the different hubs to meet the processing requirements of that specific hub. So here we're getting into the textbooks, catching up to what I was just talking about. The event hub itself can have up to 32 partitions. And now what you have within the partition, in the default handling, it round robins and puts the information into the hub in a round robin manner. And then within that partition, it processes them from the first item in to the last item in that order, that FIFO order you're dealing with. But if you're not worried about the order in which all the items are going to be published in there, that works out quite well. But we do have that capability of targeting specific events or specific information going to very specific partitions you're dealing with. As with everything in Azure, you want to make sure that you're provisioning and giving the correct access to do the activities that you need to perform. So in this case, we've got a specific set of roles for the hubs themselves. We've got owner roles, we've got reader roles, and we've got like contributor roles that you can work with, so senders and receivers. You see those roles listed for you on the screen here. Make sure that you're not over provisioning. And remember that the difference between an owner, receiver, and sender, a receiver can only read the information, a sender can write the objects to the hub, as well as the owner then has the capability of managing the permissions and potentially change the entirety of the hub itself. So make sure that you're not over provisioning those. So this gets us into a lab where we're going to actually create an event hub and then populate it with some activity.
In this lab, you're going to create an Azure Event Hubs resource and then build a .NET console application, send and receive events to the hub. Let's get into this. I'm going to start off by instantiating some variables that I'm going to be using in my scripts. Next, I'm going to create an Event Hubs namespace. Now that's being created, I'm going to go show it to you in the portal. Go to my resource group. And there's the Event Hub namespace. Next, I'm going to create an Event Hub named My Event Hub. Next, I'm retrieving the user principal name for an account that will represent the role that will be assigned to it. This is going to retrieve the event ID of the Event Hub namespace, and this resource ID will then set the scope for the role assignment for the specific namespace. This is going to create and assign the Azure Event Hubs data owner role, which will give the permissions to send and retrieve events. These commands are going to create a directory to contain the project and then change to that directory. This is going to create the .NET console application. This is adding the Azure.messaging.events hub and the Azure.identity packages to the project. I'm going to get in and edit the application and put in the code that I want to run. So you saw that we were able to run the application, make the connection to the event hub, and extract and retrieve some events. Let's go back to the recording.
Okay, welcome back from the lab. We're going to close out this module with our knowledge check. Question number 1, which event hub's concept represents an ordered sequence of events that are held in the event hub? Go ahead and pause the recording. That would be the partitions. Remember that the ordering is only withheld within the partition, not in the multiple partitions if you have them within your hub itself. Question number 2, which process represents when an event processor marks or commits the position of the last successful processed event within a partition? Go ahead and pause the recording. Checkpointing is the process that is the mark or the demarcation of that delineation that you need to when something has been processed or not. So this brings us to the close of module number 2, where we took a look at the second of the event-based processing capabilities that we had in our queue conversation. We saw that in total, there are 5 different queues that we can use to decouple activities in our modern application design. There are 2 that fell into the event processing in the event grids and the event hubs that have been covered in this learning path. We saw that for event grids being a kind of entry-level basic component to capture activity, you can now have publishers and subscribers, or a streaming model in which you could then have subscribers listen to that event grid and pull actions out of it, and based that on that, have some handler perform some other activity. We saw that in replace of maybe a traditional Kafka environment, we now have an enterprise-grade event hub that provides larger scale and enterprise-grade capabilities that wouldn't be available at the event grid capability. We saw that it had partitions, ways that you can monitor and get ordered delivery capability that you wouldn't have gotten out of the event grids. So with that, that concludes the event handling process of our queues. Thank you for joining me in this recording. I look forward to seeing you in other recordings.